Alright, this is the third video for working with radicals. This is the third thing we're going to learn. We're going to learn how to add and subtract radicals together. Now, the reason it's the third thing is because we may use the multiplying and the simplifying to solve these, okay? Multiplying maybe not, but simplifying yes. So you need to make sure that you understand how to simplify radicals before you do this. Now there's a couple things to remember when you add and subtract radicals. When you're adding or subtracting, they must have the same radicand. Alright, that's extremely important. The number underneath the radical sign has to be the same on the 2, 3, or 4 things that you're adding or subtracting together. The radicand has to be the same. And the second thing is that your root, your radicand, will not change. You might have to simplify it, which is step 3, or point number 3 here. You may simplify it to get it to be the same radicand, but throughout the problem when you're adding and subtracting, the radicand doesn't change. The root will not change. The number out front will. Alright? And I'll show you what I mean when we look at these examples. Now the third bullet point, I said it kind of with the second, you may need to simplify first to get the same radicand, and that's why we have to understand how to simplify radicals before we can do this. If I have some number, two radicals that don't have the same radicand, I may be able to simplify them down to get them so that they do, and then I can add or subtract them together. Okay? We've got 4 examples here. They go increasingly more difficult as we do them, so stay with me. This first one's going to be fairly simple. We have 3 square roots of 5 plus the square root of 5. Now, remember the first thing, we have to have the same radicand, the same number underneath, and in this example we do. They both have a 5 under the radical. The second thing, the root won't change, the number out in front will. So we need to make sure we know what the number out in front of each of these are. This first expression, 3 square roots of 5, 3 is out in front. Second one, remember there is a 1 that's not written, it's understood to be there out in front. And then we're going to add these together. Well, I have 3 square roots of 5 plus 1 square roots of 5, that gives me 4 square roots of 5. And you can think of it as saying like I have $3 and somebody gave me another $1, well I have $4. Or I had 3 apples and somebody gave me another apple. I have 4 apples. You treat that square root of 5 as something, and I want to know how many of them I have. Well, I had 3, I got another 1, now I have 4 square roots of 5. So there's the answer to the problem, 4 square roots of 5. Let's look at our second example. We have 2 square roots of 3 minus the square root of 8. Notice they don't have the same radicand. So we should see if we can simplify them. See if we can break down 8. 8's going to be 4 and 2. 4 is our perfect square, which means the square root of 4 is 2. 2 goes out in front, and a 2 stays underneath. Everything else in the problem stays the same. 2 square roots of 3 minus now 2 root 2 instead of the square root of 8. I didn't have to break down the first one because I already know 3's prime, it's not going to simplify, so I could leave it the way that it is. Now I'm going to see if I can subtract these two. Well, they still don't have the same radicand, so I can't. That means I leave my answer the way that it is. Okay, I leave it as 2 square root of 3 minus 2 square root of 2. I cannot combine those two because they don't have the same radicand. Even though I simplified it, they still don't have the same radicand, so I leave it the way that it is. Let's look at our third example. We have the square root of 75 plus the square root of 80 minus the square root of 108. We're going to see if we can get these all broken down so that they have the same radicand. Because at this point they don't. I have 3 separate numbers. So let's start with 75. We want the biggest perfect square that goes into 75. Well, 25 times 3 is going to work. 25 is the biggest perfect square. The square root of 25 is 5, goes out in front, and our 3 stays underneath. Let's look at our 50 now. To get 50, we can have 25 times 2. 25 is my perfect square. I'll bring my plus sign down. So 5 goes out in front, that's the square root of 25, and my 2 stays underneath. I need to bring my minus sign down. Let's break down 108. We need the biggest perfect square that goes into 108, and it's going to be 36. Remember, if I can't figure it out, I need to start going through my list of perfect squares until I find one that works. 36 times 3. 36 is our perfect square. Square root of 36 is 6. 3 stays underneath. Now we look and we see if we can combine anything. Well, all 3 of them don't have the same radicand, but the first and the last do. So I can combine those two, and in the middle term, it stays out just like that second example. It won't combine with anything. So we're going to combine 3 square roots of 5 minus 6 square roots of 5. I had $5, I gave 6 away, now I'm 1 in the hole. So I have a negative square root of 3. I can put my 1 in front if I want to, but I understand that it's there, so you don't have to stick it in front if you don't want to. But I had 5 root 3's, and I took away 6 of them, so now I'm 1 in the hole. And then I bring down plus 5 square root 2, because that won't combine with anything. And then there's my answer to the problem. Okay? So if you have more than 2 radicals in a problem, you may be able to combine 2 or 3 of them if you have 4, but all of them may not combine together, so pay attention to that. Final example, we have the square root of 80 plus the square root of 12 plus the square root of 45. None of them have the same radicand to start with, so we got to break them down. Let's start with 80. Square root of 80. We want the biggest perfect square that goes into 80. Well, I know 4 will go in there. 4 times 20 will give us 80. But is that the biggest one? I'm going to keep going through my list. I'm going to try 3. 3 gives us a decimal. It doesn't work. So let's try 16. Sorry, I didn't mean 3. I meant 9. Let's try 16 now. 16 and 5. Alright? 16 is our biggest perfect square. Square root of 16 is 4, so a 4 is going out in front. A 5 stays underneath. Bring our plus sign. We've broken down the square root of 12, I believe, before, so that one should be fairly easy for us. 4 and 3. Square root of 4 is 2. 3 stays underneath. Bring down our plus sign. Let's break down 45 now. 45 is really 9 times 5. 9 is our perfect square. Square root of 9 is 3. And we leave 5 underneath. Now we combine what we can. Notice the first and the last, they have the same radicand. The middle one does not. So I have 4 square roots of 5 plus 3 square roots of 5. 4 plus 3 is 7, and I put square root of 5 with it. And then I bring down 2 square roots of 3 because it won't combine. And there's my answer to the problem. 7 square roots of 5 plus 2 square roots of 3. Now, if you have any questions, go back and watch the video or bring them to class next time. And those are your notes on adding and subtracting radicals.